Welcome to our second unit in calculus. In this unit, we're going to start exploring the derivative. The derivative is really the driving force of this entire class. In this first video, we are going to understand how to estimate what a derivative is from some data and from some graphs. We're going to understand where a derivative does not exist, and we're also going to start developing an understanding of what a derivative is. Derivatives really are three different things. You want to think about derivative as always, you want to think about it as slope. Derivatives can be the slope of the line tangent to the graph. That's what I have pictured here on my right. I have this graph of like a cubic equation, and I've drawn this line tangent to that particular graph, which touches the graph just one time. The slope of that line would be the derivative at that particular point. A second thing that a derivative would be the velocity of a particle moving in rectilinear motion, and it also is considered the instantaneous rate of change. On my first example, what I want you to do is I want you to estimate what the derivative is at 1 of x cubed plus x minus 1. To do so, we're putting that in our calculator, so I put it in my calculator. When I do that, then I'm going to change my table to ask mode. And what that allows me to do, what the ask mode allows me to do is that when I go to my table, then it's empty and allows me to type in values. What I'm going to do is I'm going to type in a value just below 1 and just above 1, and I'm going to find the slope of that line. So if I go 0.999 and then 1.001, I get values that are, pretty close to each other. And if I were to work out the slope of that line, so I were to take 1.004 minus 0.996 over 1.001 minus 0.999, I would get 4. So an estimation of what the derivative is at 1 would be 4. Just on a side note, I'll get into notation a little bit more. This little notation means f prime of 1, which means find the derivative at 1. If you go back to your calculator will actually calculate the derivative for you. So go to your graph. And then if you go to calculate on your graph, another notation would be dy dx, means rate of change of y with respect to rate of change of x. If you select that sixth one down and then you type in 1, it'll tell you the derivative at that point is approximately 4. A second type of example will be, I won't give you the equation, but then we'll just have to work with some data, and I want to estimate what the derivative is at 2.5. So right here at 2.5, the y value is 3, but that's not a rate of change. I need to find a rate of change. So I want to find the slope between 2.4 and 2.5. So if I do that, I get 9. If I do it on the high side, I get 10. So the derivative between right at 2.5, it's somewhere between 9 and 10. If you said 9.5 or if you said 9.3 or 9.6, something like that. If I give you more information about the graph, you'll be able to give me a little bit better number, but it's an estimation. So the rate of change right at 2.5, somewhere between 9 and 10. Anywhere is really okay. I'm going to give you some pictures of graphs, and when I give you the pictures of the graphs, then you're going to have to draw the tangent lines to estimate the slopes. And these ones on the left, as I'm closer to the top of the graph, the slopes are going to be less negative, but they're definitely going to be negative. As you can see, I said negative 2/7 and then negative 2/3 and negative 1, negative 4/3. As I get further and further to the right, it's going to become more negative, but they're definitely negative. On this one on the right, as I draw the slopes, now I'm going to get positive. Over here on the bottom side, it's going to be more positive, and up here it's going to become less positive. But basically what you're doing is you're drawing these lines tangent to the graph, and then you're just estimating the slopes. So like in my example of this, if I'm looking for the derivative right at 1 right here, if I were to draw a line that's tangent to the graph that goes through that, the best estimation, it would definitely be negative, and the best estimation would be, okay, well, it's about negative 2 over 1. So it's not going to be negative 1/2, but it's going to be negative 2. On my next example, I want to know what the derivative is at 3. Again, if I draw a line tangent to the graph, again, it's going to be negative. Looks like negative 1, and I'm maybe over 3, so about negative 1/3. Again, these are estimations, so I'm not going to argue with you whether that's negative 1/3 or negative 1/4. Finally, we're going to have some pictures, and you have to know where a derivative does not exist. A derivative is not going to exist wherever you have discontinuity. so any discontinuous points. And then a derivative is also not going to exist wherever you have some sharp turns. In this first one, we call it a corner. In the second one, we have a vertical tangent line, so the graph goes vertical. I'm going to specify a little bit later on in the class about when to formalize for you when a derivative does not exist. But in this first part, you're just going to be looking at pictures. So good luck on problem set number 1. We'll clarify in class for you. See you soon.